Hi, everyone. My name is Rhea Shah, and I'm a sophomore at Nobles.
My name is Jacinta, and I'm also a sophomore at Nobles, and today we're going to be talking about technological innovations and the intersection between the climate crisis and healthcare.
So first off, just a quick roadmap of this talk. We're first going to be talking about our stories and why these issues are important to us. Next, air quality issues, water pollution and water insecurity, and then we're going to follow up with some technological solutions that have been created to solve these issues, as well as some final takeaways.
So we wanted to start off with a quick question. Raise your hand if you've ever been traveling to a country and you've had to double check the air quality index or be wary of the water quality. Yeah, same with us, which is why we wanted to focus on these two topics for our presentation today.
So to start off, a little bit about my story. My family is from India. I go back pretty much every year. I go back to Mumbai, which is a big city, to visit my grandparents. And pretty much as soon as I get off the plane, it looks like that picture down at the bottom of the slide. Like, you can feel it immediately in your throat and lungs. It's just smog immediately. So what we did is we found this really cool graphic here on the side, which shows us the air quality index, and it also breaks down particulate matter and different chemicals in the air. And we'll kind of explain more about what that means later on. But for now, it's a cool graphic to look at. And in terms of water insecurity, in India, you're not able to use or drink water without boiling it. And my family is lucky enough to have running water where we can boil water and then just leave it in a little collection device like that one up in the corner. But for people who do not have running water, it tends to be that you have to go to a communal collection area, boil the water, and then store it in large quantities such as like this.
With me, my family's from Kenya, and we visit there pretty often, and you can see on the right that my uncle actually sent me a picture of the Nairobi River Basin, which is a river basin that's located near our family home in Kenya. This river basin has become heavily polluted over the years due to the dumping of untreated sewage, solid waste, industrial/plastic pollution, and agricultural runoff. The pollution in the basin leads to water that looks like the one seen on the left, which is a source of drinking water for so many families and communities. Water like this is not only extremely detrimental to people, but it also harms the wildlife and the environment surrounding it.
So in terms of the air quality is measured on an air quality index, or AQI, and it includes a variety of factors, but the biggest one that we're going to be talking about is particulate matter. So particulate matter ranges in sizes from 2.5 to 10 micrometers. And just for a diagram of how small that is, you can see it compared to a human hair, which is 50 to 70 micrometers, which shows like how incredibly small that is. And the smaller that particulate matter is, the more dangerous it becomes. So there's particulate matter 10, which are your typical allergens, such as pollen, dust, mold, things that could get stuck in your throat or lungs, and it could be dangerous in large quantities, but your body is typically able to cough or sneeze it out. However, particulate matter 2.5 is where it gets really dangerous, because those are things like combustion particles, organic chemicals, things that have been combusted. And this is why this is becoming so dangerous, because in recent years, as the combustion of carbon-based fossil fuels has become more prevalent, particulate matter 2.5 has been getting a lot worse.
Poor air quality can also lead to a number of lung diseases, and lung diseases can typically cause things like inflammation and making the body more susceptible to other particles. It can also kill cells at the alveolar capillary barrier, which is where oxygen and carbon dioxide are exchanged. If carbon dioxide can't get out and oxygen can't get in, then the body cannot properly function. Additionally, poor air quality can lead to stroke, chronic obstructive pulmonary disease, or COPD, which is basically a group of diseases that can cause mucus production, wheezing, difficulty breathing, and so many other symptoms, as well as asthma and lung and heart cancer.
So the other end of this is water insecurity. There are two sides to water insecurity, the first being droughts. The most prevalent issue is that people do not have enough access to proper drinking water. However, not having enough access to water can also affect hygiene, such as washing hands, bathing, doing the dishes, or using the bathroom, and also can cause food insecurity if people do not have enough water to irrigate their crops. Additionally, as people are trying to be more sustainable, people have been using hydroelectric power, and if they don't have enough water for that, they may be without electricity or power for long periods of time. And this graph over here is really cool, because we're able to see the spikes and drops of the dry and wet periods. Two things I want to point out are the huge spikes near the 2000s and 2010 regions, because it shows how we've had some really huge heat waves in recent years, but also this huge wet spike, which kind of leads us into the next slide about the excessive rainfall part of water insecurity. Excessive rainfall can cause cities to exceed their water capacities and can also cause huge damage to homes, buildings, and other infrastructure. If homes are damaged, people can be left without shelter, food, water, and electricity for long periods of time. And additionally, contaminants. So from a biological standpoint, contaminants such as Vibrio bacteria in seawater, which we'll go into a little bit more, can be grown with the presence of global warming and temperature rises. And additionally, harmful algal toxins such as benthic or macroalgae can grow too. And other toxins such as brevetoxins and microcystins can grow in water and seafood, which can be dangerous if we're eating something like fish or shrimp. And finally, we want to talk about the presence of PFAS, or polyfluorinated alkyl substances, which are chemicals typically found in nonstick cookware, but currently contaminate about 45% of drinking water. Luckily, this number is starting to go down because of some legislature that's been passed in recent years, but also another contaminant that we wanted to note.
Diving into one of the pathogens that Rhea talked about, Vibrio cholerae bacteria, or cholera, is caused by the bacteria Vibrio cholerae, and it is a bacterial disease that spreads through contaminated water. If left untreated, it can be fatal even in previously healthy people. Approximately 1 in 10 people who develop cholera will have severe symptoms such as watery diarrhea, vomiting, and leg cramps. And going back to our personal stories, in Kenya and the East African region account for 10% of all cases from the sub-Saharan Africa region, and the fatality rates remain above 2.5%, which is just absolutely insane. And in India, there are around 565 outbreaks in the years 2011 and 2020, which led to around 46,000 cases and 263 deaths.
So what can be done? Next, we're going to be diving into 5 different technologies that have been created to help combat these issues.
The first technology that we're going to talk about is geospatial technology. Geospatial technology collects data from multiple facets and displays it on a map. It provides accurate and detailed information about where diseases are found, accessibility to healthcare, environmental factors that affect health, disease penetration, and health risk by age, as well as other social factors. Geospatial technology also helps healthcare organizations allocate resources effectively. By mapping population density and healthcare facility regions, it tells authorities which areas have the highest need for medical resources and distributes them accordingly.
The second technology we're going to be talking about involves a company called Climate Trace. Climate Trace creates maps of how much CO2 or other pollutants are being emitted by companies or specific areas. And it'll give data to these companies so that they can make changes in how much they're emitting. And the idea is to make this also open to the public so that people can gain this knowledge as well. This works by using infrared heat sensors in combination with satellite imagery of smoke to create a cohesive data set that looks much like this map down here on the bottom of the slide. And this is really cool because we're able to see some of the biggest hubs where the most emissions are coming from, such as the northeast of the US, Europe, India, and China.
Microdrip irrigation is one of the current technologies that's helping combat the drought crisis. It does this by delivering water straight to the roots, which allows for less contamination and less waste. Traditional irrigation methods like flood irrigation increase the likelihood of waterborne diseases by spreading contaminants, while microdrip irrigation lowers this likelihood by minimizing water contact with crops, therefore reducing the spreading of pathogens.
In terms of the filtration of actual drinking water, villages in rural Bangladesh have been using sari cloths to filter out cholera. Saris are typical Indian garments made out of cotton, and there was a study done in 2002 that compared these cotton filters to nylon, and it ended up being that the cotton filters were the most efficient in filtering out the cholera, and they were also very accessible to a lot of people. So what they'll do is they'll basically fold up these cotton cloths about 8 times, put them over a water collection device, and then when people go to a communal water source, such as a lake, river, or pond, they're able to filter out the zooplankton, which is hosting this cholera, allowing them to have safe drinking water for drinking, of course, but then also other household use. And scrubbers remove air pollutants from industrial exhaust. Some pollutants include sulfur dioxide, chlorine, dihydrogen sulfide, and hydrogen chloride. And these wet scrubbers will spray out a liquid into the exhaust, picking up the target gas, whereas dry scrubbers will spray dry reagents into exhaust, neutralizing the target gas.
Despite the magnitude of air and water pollution challenges, innovative technological solutions and collective action are offering hope for a brighter, healthier, and more sustainable future. Thank you.